We're going to take a look at the sum rule for differentiation. So this is the most straightforward of the rules we need to prove. And this is very straightforward. It simply says if a function f of x is u of x plus v of x, then when you differentiate this, you just differentiate each of these individually and add them. So we're thinking about, for example, like a place where you would use this is, suppose f of x equals x squared plus 3x. Well, this means to get the derivative of this function, I just differentiate each of these two separately. So I differentiate x squared and I get 2x to the power of 1, or 2x. I differentiate 3x and I get 3. So to do this, I'm using the sum rule. So I can differentiate this, and add the answers. So that's an example. Okay. In order to actually prove it, what we're going to do is we're just going to go right back to the definition of the derivative. So f dash x is the limit as h tends to 0 of u of x plus, of f of x plus h minus f of x all over h. So that's the definition of our derivative. What we're going to do is we're going to fill in this and this, and we're going to show that it equals to the derivative of each of them individually. So let's do that. So in order to use this, we build it up. So we say, well, f of x plus h is u of x plus h plus v of x plus h. Alright, all we do is we take this here, and if we're putting x plus h in here, then we put x plus h in here and x plus h in here. Same way that if we're getting f of 2, it would be u of 2 plus v of 2. F of 11 will be u of 11 plus v of 11. So f of x plus h is u of x plus h plus v of x plus h. So that means the top line, f of x plus h minus f of x, is going to be u of x plus h plus v of x plus h. So that's the f of x plus h bit. And then we take away f of x. So we take away u of x plus v of x. Okay, so that's f of x plus h, take away f of x. So what we're going to do is we're going to multiply the minus in, and we might as well group the u's together and group the v's together. Alright, so we get ux plus h minus ux plus vx plus h minus vx. Okay, so for the whole fraction then, f of x plus h minus f of x over h is equal to, okay, so we need to take this right hand side and divide it by h. So once again, we'll think of it as coming in two parts. So u of x plus h minus u of x all over h. So we've kind of grouped the two of these together, divide them by h, and then we've grouped the two of these together, so we have to divide them by h. So v of x plus h minus v of x all over h. Okay, so we have the first bit divided by h plus the second bit divided by h. Right. The last step in getting the derivative is we take the limit. So let's do that. So therefore, f dash x is the limit as h tends to 0, f of x plus h minus f of x all over h. So that's the limit as h tends to 0 of ux plus h minus u of x over h. Right, so it's the limit of this first bit. So the limit of the left hand side is the limit of the right, fair enough. So that's the limit of the first bit plus the limit of the second bit. So plus the limit as h tends to 0 of v of x plus h minus v of x over h. Alright, so the limit of the left hand side is the limit of the right hand side, and the limit of the right hand side is the limit of this bit plus the limit of this bit. Now we're pretty much finished. So the limit as h goes to 0 of u of x plus h minus u of x over h, well, that's just u dash x. And this limit here, v of x plus h minus v of x over h, the limit of that as h goes to 0 is just v dash x. And we're finished. So that's it. We simply fill in the formula that we have. We kind of build up the formula, find what this is, find the whole top line, divide by h, take the limit. Right, so we differentiate from first principles. And just remember to group the u's together, group the b's together.